Good morning. In this video, we are going to start with chapter 3, pair of linear equations in two variables. Linear equation in two variables, the general form is given by ax plus by plus c equal to 0, where a and b are both not 0. Both should not be 0 at the same time. For example, 2x plus 3y equal to 5. We have already seen how we check for the solution of this. So solution will be given as a pair of values x comma y. So first we'll write x and then we'll write the y. For example, if we consider the number 1 comma 1, if we substitute in LHS 2 into 1 plus 3 into 1 is equal to 5, which is equal to the RHS. So it is a solution. If we are substituting 2 comma 2, then we get the answer to be 10, which is not equal to 5, which is our RHS. So this is not a solution. So 1 1 is a solution while 2 2 is not a solution. Now graphically, if we are drawing this line 2x plus 3y equal to 5, then 1 1 will lie on the line and 2 2 will not lie on the line. So let us see. See, this is the graph of 2x plus 3y equal to 5. We have the line and 1 1, the line passes through the point 1 1, but it does not pass through the point 2 2. So this is not a solution. So from this we can tell that all the points that lie on this line are the solution for this line. So each solution of a linear equation in two variable corresponds to a point on the line representing the equation and vice versa. That means every point is the solution. Okay. Now let us see pair of linear equations in two variables. The general form is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1, b1, c1, a2, b2, c2 are all real numbers and a1, b1, a2, b2 should not be 0. Okay, otherwise it will become a single variable. Now, what are the possibilities when we are having two lines? Either they can intersect at one point, as in option A, or they can be parallel, like in option B, or they can be one and the same line, as in option C. If they are the same line, it is called as two lines are coincident. Now, let us see an example. Exercise 3.1, question number 1. Aftab tells his daughter, 7 years ago, I was 7 times as old as you were then. Also, 3 years from now, I shall be 3 times as old as you will be. Represent the situation algebraically and graphically. So first, let us see the algebraic representation. So we'll assume present age of Aftab to be X and the present age of his daughter to be Y. 7 years ago, age of Aftab is x minus 7, while that of his daughter will be y minus 7. Both we have to subtract 7. According to the question, I was 7 times as old as you were then, 7 years ago. So x minus 7 is 7 times y minus 7. When we solve, we get the first equation, x minus 7y equal to minus 42. 3 years hence, after 3 years, age of Aftab will be x plus 3 and age of his daughter will be y plus 3. So according to the question, x plus 3 is equal to 3 into y plus 3. So when we solve it, we get x minus 3y equal to 6. So we have represented the situation algebraically. Equation 1 and 2 are the algebraic representation. So let us move to graphical representation. Now that we got the equations, x minus 7y equal to minus 42 and x minus 3y equal to 6, we are going to draw the graph for this. You have already studied this in 9th standard. So I'm just going to quickly go through it. We are assuming points for x and y and solving it. So we get two lines and both the lines are intersecting at a point. So this is the graph that we are having here. So this is the graphical representation of the situation. Now, whenever we're seeing pair of linear equations in two variables, solution can be obtained in two ways, as in the way we saw in the previous question, graphical method as well as algebraic method. So in this chapter, we'll be going in detail about each method. The graph of a pair of linear equations in two variables is represented by two lines. If the lines intersect at a point, then that point gives the unique solution of the two equations. So whenever we are considering two lines, if they cut each other at a single point, then that point is called as the solution of those two equations. For a single line, every point on the line was a solution. For two lines, the common point of these two lines will be the solution. So this is an important table. We are having how to identify what type of equations they are without actually solving them or without actually graphically representing them. For that, we need to consider their ratios. A1 by A2 is not equal to B1 by B2, then the lines are intersecting and they have only one solution. If A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then they are coincident lines and they'll have infinitely many solutions, because what are the common points for the same line? Everything. So each and every point will be a solution. If A1 by A2 equal to B1 by B2 but it is not equal to C1 by C2, then the lines will be parallel and they will not have any solution because there is no common point between them. Consistency of a solution. If a pair of linear equation has no solution, then the linear equation is called to be inconsistent equation. For example, when the lines are parallel. And if they have a solution, whether it be unique or infinitely many, then the equations are said to be consistent equation. So either they'll have unique solution or they'll have infinitely many solution. That doesn't matter. If they have a solution, then we call them to be consistent. Now let us continue with exercise 3.2. Question number 1. Form the pair of linear equations in the following problem and find the solutions graphically. 10 students of class 10 took part in a mathematics quiz. If the number of girls is 4 more than the number of boys, find the number of boys and girls who took part in the quiz. Let the number of girls be x and let the number of boys be y. According to the question, x plus y is 10 because totally 10 students are there, and number of girls is 4 more than the number of boys. So x minus y will be 4. Now we'll represent that graphically, and we find that these two lines intersect at the point 7, 3. So from the figure, it can be observed that these lines intersect each other at 7, 3. Therefore, the number of girls and boys in the class are 7 and 3 respectively. So 7 girls and 3 boys. So their difference is 4 and their summation is 10. So this is the answer. Now the next one, on comparing the ratios A1 by A2, B1 by B2, C1 by C2, find out whether the lines representing the following pairs of linear equations at a point are parallel or coincident. So we are having two equations. Now comparing equations with the general form A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 equal to 0. We get A1 as 5, B1 is minus 4, C1 is 8. A2 is 7, B2 is 6, and C2 is minus 9. So first we find A1 by A2, 5 by 7, B1 by B2, minus 2 by 3. They both are not equal, hence they have unique solution and the lines intersect exactly at one point. The second equation is 9x plus 3y plus 12 equal to 0, 18x plus 6y plus 24 equal to 0. Again, comparing with the general form, we get that A1 is 9, B1 is 3, C1 is 12, A2 is 18, B2 is 6, C2 is 24. A1 by A2 is 1 by 2, B1 by B2 again 1 by 2, C1 by C2 also 1 by 2. So that means A1 by A2 is equal to B1 by B2, which is equal to C1 by C2. Hence, the lines are coincident and they'll have infinitely many solutions. Moving on to the third question, 6x minus 3y plus 10 equal to 0, 2x minus y plus 9 equal to 0. So comparing again with the general form, we get A1 as 6, B1 is minus 3, C1 is 10, A2 is 2, B2 is minus 1, C2 is 9. A1 by A2 is 3 by 1, B1 by B2 is 3 by 1 again, C1 by C2 is 10 by 9. So A1 by A2 equal to B1 by B2, but it is not equal to C1 by C2. That means these two lines are parallel. There are no common points, so no solution for these two equations. Now moving on to the third question, comparing the ratios, check whether the equations are consistent or inconsistent. So we have two equations. Again, we are going to compare them with the general form and check the ratios. We get A1 by A2 equal to 1 by 2, B1 by B2 1 by 2, C1 by C2 8 by 9. So A1 by A2 equal to B1 by B2, but it is not equal to C1 by C2. That means these two lines are parallel. Parallel means they are not going to have any solution. No solution, inconsistent. So the pair of linear equations are inconsistent. The next one, we are having fractions. 3 by 2x plus 5 by 3y equal to 7. 9x minus 10y equal to 14. So we'll write it in the standard form first. 3 by 2x plus 5 by 3y minus 7 equal to 0. The other equation minus 14 equal to 0. Comparing the ratios, A1 by A2 is 1 by 6, B1 by B2 is minus 1 by 6, C1 by C2 is 1 by 2. So A1 by A2 is not equal to B1 by B2. That means they are going to intersect at a single point. They'll have a unique solution. So therefore, the equations are consistent. Now moving on to the third one, 5x minus 3y equal to 11 minus 10x plus 6y equal to minus 22. So A1 by A2 is minus 1 by 2, B1 by B2 is also 1 minus 1 by 2, C1 by C2 again minus 1 by 2. So A1 by A2 equal to B1 by B2 equal to C1 by C2. So they are one and the same coincident lines, and they'll have infinite number of solutions. Anyway, they are having solution, so the equations are consistent. Now moving on to the word problem, question number 5. Half the perimeter of a rectangular garden whose length is 4 meter more than its width is 36 meter. Find the dimensions of the garden. Let the width of the garden be x and the length be y. According to the question, length is 4 more than its width. So y is 4 plus x. So y minus x is 4. That will be a first equation. Half the perimeter of the rectangular garden is 36. So y plus x is 36. That will be our second equation. So let us represent that graphically. We find that after drawing it graphically, these two lines are intersecting at a point 16, 20. So length and width of the garden are 20 meters and 60 meters because we had taken a length to be y and width to be x. X coordinate is 16, so width is 16 meter. Y coordinate is 20, so length is 20 meters. With this, we have come to the end of this session. We'll continue in the next video. Thank you.